ahead. Good afternoon, Sergeants. Today we'll be going over task 071, Charlie Oscar Mike 1016. Sergeant Messegee, I'll be teaching it. Before we begin class, I'd like to go over some administrative tasks. The overall risk level is low. A few hazards and controls in our environment. Please watch out for any cords laying across walkways. If you see them, you just go ahead and wrap them up, or just let me know. And just overall be cognizant of hazards while navigating the training area. Electrocution, keep containers without lids away from electronics and outlets. Dehydration, drink adequate amounts of water throughout the training exercise. And inclement weather, just stay away from the windows and go to a tornado shelter in case of severe inclement weather. Additionally, the Army is a green Army, so the Army green policy, reduce, reuse, and recycle. We'll conduct a police call later on to ensure we don't leave any equipment or trash behind. In the event of an active shooter, we will run, then hide. We will run, then hide, then fight, if it does come to that. Also, before I start class, we'll be doing initial PCCs and PCIs. Please get out a pen and paper, water source, ID card, and map. All right. I would check all these items individually and hands-on, and then I would make checks on my PCI checklist. All right, I'll now begin teaching the class. Again, this is task 071, Charlie Oscar Mike 1016, converting azimuths. All right, conditions. You're a member of a squad preparing to conduct tactical movement, and you've been directed to convert azimuths in preparation for the movement. You've been given a 1 to 50,000 scale map with a declination diagram, pencil, paper, a magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mach 4. Standards: convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth without error. Special conditions, none. Special standards, none. The safety risk is low, and Mach 4 sometimes. We aren't going to be doing any iterations in Mach 4 today. All right, and then as a note, the north-south lines designate grid north on your map. The compass needle points to magnetic north. The grid magnetic GM angle is the angle difference between grid north and magnetic north. All right, so I'm gonna read all notes, cautions, and warnings in the order that they appear. All right, so warning. When converting azimuths into back azimuths, extreme care should be exercised when adding or subtracting the 180 degrees. A simple mathematical mistake could have disastrous consequences. So even though this is a simple task, please just be careful because any small mistake could have a huge impact on your mission. All right, step 1, convert an azimuth into a back azimuth. Add 180 degrees if the azimuth is 180 degrees or less. All right, so if you have less than 180 degrees, you're simply going to add 180. Subtract 180 degrees if the azimuth is 180 degrees or more. So if you have 180 degrees or higher, you're going to subtract 180 degrees. You're literally just doing a 180, just turning right around. That's a back azimuth, guys. All right. We're going to convert a magnetic azimuth to a grid azimuth. Note, to convert a magnetic azimuth to grid azimuth, subtract the GM angle. Warning, when converting azimuths into back azimuths, extreme care should be exercised when adding or subtracting the 180 degrees. A simple mistake of 1 degree could be significant in the field. All right, so if you're going like 10 clicks and you're even just 1 degree off, that could be a pretty big difference, guys. So just be careful. Locate the GM angle, which is part of the declination diagram at the bottom of your map. The declination diagram shows both a graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils. All right, so here's your declination diagram with the GM angle highlighted. We're going to be using 9.5 degrees, 170 mils. Determine whether the GM angle is easterly or westerly. Apply the mathematical formula to convert a magnetic azimuth to a grid azimuth. Step 1. Add an easterly GM angle to a magnetic azimuth to obtain a grid azimuth. So if you're going to obtain a grid azimuth, we need to add our easterly GM angle to the magnetic azimuth. And that's going to give us our grid azimuth, okay? All right, step 2, subtract a westerly GM angle from a magnetic azimuth to obtain your grid azimuth. So you have your magnetic azimuth, you're going to subtract your westerly GM angle, and that's going to give you your grid azimuth, okay? So as an example, given a magnetic azimuth of 190 degrees, using the above diagram, you would add 9.5 degrees to 190 degrees to obtain a grid azimuth of 199.5 degrees. All right. Convert a grid azimuth to a magnetic azimuth. Locate the GM angle, which is part of the declination diagram, at the bottom of your map. Note, the declination diagram shows both a graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils. It's just the same map as before, guys. All right. Apply the mathematical formula to convert a magnetic azimuth to a grid azimuth. Subtract an easterly GM angle from a grid azimuth to obtain a magnetic azimuth. So you're going to subtract the easterly GM angle from your grid azimuth to then obtain your magnetic azimuth, okay? Add a westerly GM angle to a grid azimuth to obtain a magnetic azimuth. Note, as an example, given the grid azimuth of 199.5 degrees, using the above diagram, you would subtract 9.5 degrees from 199.5 degrees to obtain a magnetic azimuth of 190 degrees. All right, the rest of this is just evaluation stuff. All right, before we get into that, does anyone have any questions about the demonstration so far? All right, I would answer any of those questions. All right, you'll be given 5 minutes to practice, and I'll be going around helping as needed. I'll be making sure to fix any mistakes that anyone is repeating or anything like that, and making sure that I'm not filling out paperwork and actually helping them out. All right, 5 minutes has elapsed. This concludes our practice. Does anyone have any questions? All right, I'll reiterate the task conditions and standards verbatim before we begin the evaluation. Task 071, Charlie Oscar Mike 1016, converting azimuths. Okay, so conditions. You're a member of a squad preparing to conduct tactical movement, and you've been directed to convert azimuths in preparation for the movement. You've been given a 1 to 50,000 scale military map with a declination diagram. Pencil, paper, a magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mach 4. Convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth without error. Special conditions, none. Special standards, none. Safety risk is low, and Mach 4 sometimes. All right. I'd like to inform the audience that if any PM has failed, the evaluation is over. I will now evaluate one soldier. All right, evaluation complete. All soldiers have not passed this task. 2 trained, 4 untrained. Sergeant Schindler, I'd like to let you know that my squad is untrained. For any soldiers that failed or did not get the opportunity to train, retrain and evaluation, time, date, location, and uniform will be 1300, 30 July 2021. Location will be behind the field, behind the battalion, the field behind battalion. OCPs with a water source. Equipment is the same as it was today. We will now conduct a police call and do a PCI of all training aids. All right, so we're gonna do the police call first, and then we'll do the PCI, so everyone get online and we'll do the police call. All right, police call is complete. All right, for our PCI, please get out a pen and paper, water source, ID card, and map. I would check all of these items with hands-on and individually. I would make checks on my PCI checklist at this time. All right, and then I would also gather my training aids up, make sure that there is no damage to any of them. All right, so we're gonna go ahead and review the draw, and then we will conduct an AR. All right, so the draw, our hazards were cords laying across the walkways, which we're just gonna wrap loose cords up and be cognizant of hazards while navigating the training area. Electrocution, keep containers without lids away from electronics and outlets. Dehydration, drink adequate amounts of water throughout the training exercise. And inclement weather, just go ahead and stay away from the windows, and in case of severe inclement weather, go to a tornado shelter. All right, let's go ahead and do our AAR. All right, so everyone has a right to speak, and I want to encourage maximum participation. Please don't talk over each other and always be respectful of differing viewpoints. It's okay to disagree, it's just not okay to be disagreeable, okay guys? All right, so what was supposed to happen? What was supposed to happen was a brief, deliberate risk assessment, do a PCI, task, conditions, standards were read verbatim, and I introduced myself to you guys. You were then given step-by-step instruction, and I demonstrated each step for you. Then I asked you for any questions, gave you 5 minutes to practice. I restated the task, conditions, and standards verbatim, and read those to you guys. I then evaluated one member of the squad, provided feedback and report the assessment to the squad, to my leadership, and then I stated the time, date, location, and uniform for retrain. We made sure we did another PCC and PCI, as well as a police call. All right, so what happened? Okay. What are some things that you guys went right? All right, what went wrong? Okay. How could I improve my training for next time? All right, so just to summarize for you guys, I told you what was supposed to happen throughout us learning this task. You told me what you thought did happen. You told me what went right with the training and what went wrong, things we could fix for next time, and then how I could improve the training for next time. So keep those things went right, fix the things went wrong. All right. Was anyone injured, or was there any of your guys' equipment damaged? I know all the training aids, there's no damage to any of those. Okay, so no injuries and no damaged equipment. All right, were all control measures implemented effectively? I'd say yes, because there's no injuries and no damage to any equipment. Would you guys agree? Okay. Awesome. Well, thank you all for coming. That concludes my training. Sergeant Schindler, I'd like to request to close out my training site.